Monster Laboratory here. I previously removed this rumble motor from my Xbox controller. Today I'm going to show you the best way to turn this motor into an Arduino sound-activated DC motor. By the way, this also works for other DC motors as well. Well, here's my setup for the sound sensor activated motor. Every time I speak, you can see the LED light up on the sound sensor module. This is a 4-pin sound sensor module. They're very popular. And you can adjust the sensitivity to this sound sensor by this little screw up here on top of the potentiometer, and then the speakers right here in the front. The important thing is this motor is not connected to my Arduino. Now there is a possibility that it could destroy my Arduino because it could draw more power than the Arduino can handle. So what we've done is used an L293 IC, integrated circuit. That is an excellent motor driver for these small motors like this right here. And you can actually hook two up to one IC. I can hook another one up on the other side. If you want to know more about the L293 motor driver IC, I will link a video in the description below. You can check that out. I do talk about it a little bit more. Over here we have the Arduino, and it is connected to the breadboard through a ground pin and the ground rail. And the breadboard is powered through this breadboard power supply over here with a 9-volt plug, wall adapter plugged into it. And I can control the power using this switch right here on the breadboard. Now, this is a 4-pin sound sensor, and you can change the sensitivity with this screw right here on top of the potentiometer. Now, we don't want to power our motor through our Arduino board directly. There are several ways to do it, but I think the best way to do it is through a motor driver. And with this one we can control the direction of the motor spin and the speed of the motor through pulse width modulation. Here's the motor that I used in the short that I did, which surprisingly got a lot of questions about how I did this. This motor actually came from an Xbox remote. I took one apart, actually I took two apart, and I took the motor out. There's this motor and a smaller motor just like it on either side of the controller. And what I did in the video was just I whistled, but every time I talk, it can sense my voice and it will activate. Here's the schematic for you real quick. I'm using a 3 to 6 volt motor here. That's basically the same as the Xbox controller motor, as in the sense that they both have two leads coming from them. If you look at the sound sensor, you can see that the A0 pin is connected to the A0, the analog 0 pin on the Uno board, and the D0 pin is connected to pin 5 on the Uno board. And then I have 3 pins from the IC chip, and they're connected to pins 7, 8, and 9. And I hope this helps you out if you're looking to replicate this same project. And remember that the little dimple on the IC chip is in the bottom left corner, and that is the location of pin number 1. Now if you're looking for another way to do this, you could use a 5-volt relay module. Typically these modules are used to separate a very high voltage, say a lamp or a television, from a smaller voltage, say a 5-volt Uno board or other microcontroller. And it does this by way of optocoupler right here in the middle. So this does allow us to operate the DC motor by using an external power source like the breadboard power supply, while at the same time being able to control that motor using the Arduino board and keeping those circuits separate so that it doesn't damage our microcontroller. If you're looking for a third way to do this, you could use a logic level MOSFET instead of a relay module or a motor driver IC. I do not have one at the moment, so I apologize, it's not part of my example here. Well, here's a look at the code, and we're going to start our code out up at the top here, just defining the pins on our Uno board. And then down here we set the pins up as, in the setup, we set them up as inputs and outputs. And then down here in the loop, we're going to read from the A0 analog pin, and then we'll read from the digital pin, pin 5. We'll also turn on the enable pin, and give it a value of 255. So it says that if the digital value is high, then the IN1 is high, IN2 is low. That just means the rotation is going to be one direction on the motor. And we'll see in the serial monitor, we'll get a message that says motor on. It'll be on for 1 second. If we see that the digital value is low and not high, then it'll fall under this other statement here under else, and it'll execute this code where it keeps IN1 and IN2 low, and then it'll go for a short delay. If you wanted to rotate the motor in the opposite direction, you could set ion 1 to be low and ion 2 to be high. Now that would turn you in the opposite direction. Now if I go up here and click serial monitor, we can see the value that the sensor is giving us, and every time the LED lights up on here, you can see motor on. That means it's met the threshold that you set with the sensitivity screw right here. But the best way to look at this is probably with the plotter, which you can get to right here. Of course, it puts it on the other screen. And as I'm speaking, it is plotting the different values, and this just helps you visualize what your sensor is hearing. And also, if you're having trouble with your sound sensor picking up any sound, you can look right here and you can tell, well, maybe you have a connection that is wrong or something's wrong with your sensor. So this is very helpful. Well, I hope this was helpful, and I hope it cleared up any questions you may have had about the wiring or the code for the video that I did previously. Thank you very much for watching. If you enjoyed the video, be sure to give it a thumbs up and share it with somebody who might enjoy it as well or might find it useful. And if you haven't done so yet, maybe consider subscribing to the channel, and I will see you again very soon. Thank you.